All right, we are going to work on this Algebraic Reasoning Unit 4 test review. So number 1 says these are the parent functions, and we're going to list the key features. So a linear function, I'm going to add arrows on the end of this, is a line, f of x equals x, or y equals x. That's my parent function without any transformations. It goes through the origin, so it has x and y intercepts at 0, 0. Okay. The domain and the range of the linear parent function are both all real numbers. Which means that it goes on and on and on to the left forever and to the right forever. That's my domain. My range, it goes down forever, it goes up forever. That's all real numbers as well. We don't have any asymptotes or vertices or anything like that on a linear function. Okay, so moving over to absolute value, again, I'm going to add arrows on the end of this. I do have x and y intercepts again here at the origin. And that is also called my vertex. This specific one, the absolute value of x, or y equals the absolute value of x, is going to have a minimum at the vertex. I don't have asymptotes or anything like that on this one. My domain, again, is all real numbers based on these arrows that I go forever to the left and forever to the right. But my range, I definitely have a lowest point that I was talking about over here at the minimum. My lowest point is 0. So my y values are all greater than or equal to 0. In my quadratic, I have that U shape. And this is y is equal to x squared as my parent function. Again, my x-intercepts 0, 0. My y-intercept is also at 0, 0. That is also called my vertex at 0, 0. It is a minimum again. My domain is all real numbers because I go forever to the left and forever to the right. And my range, everything is greater than 0 again. And that's because I have the minimum. Okay, and the last parent function that we have to look at is the exponential. Now we have growth. Oops, sorry about that. We have growth where we are increasing from left to right, and we have decay where we are decreasing from left to right. So again, we've got arrows here. If our b value is greater than 1, we're going to have growth, something like 2 to the x power or 4.7 to the x power. Something like that is growth. Decay, our b value is going to be between 0 and 1, so maybe 1/2 to the x power or 0.3 to the x power, something like that. Okay, so the x-intercept, we actually don't have one. On the parent function. The y-intercept kind of depends on what your base is, because a y-intercept always happens when your x value is 0. So on these parent functions, it should be at 1, but it all depends on if there's a number in front of your b value, if you had an a value. But here we don't on these parent functions. So any number that we take to the 0 power is going to give us 1. So that's our y-intercept, would always be at 0, 1. Our asymptote is this dotted line that I'm going to draw in here that my graph never touches and never crosses on an exponential function. So our line just kind of curves down and gets close to this asymptote. That's at y equals 0 for the parent function. Just like all my other functions, And last is my range. And my range depends on where that asymptote is. And in this case, my asymptote is at y equals 0. So my range is going to be y is greater than 0 for both the growth and decay. Now, on some of the other ones, I put greater than or equal to 0 on both the absolute value and the quadratic. And those are greater than or equal to 0 because we're actually touching that point 0, 0 on both of these graphs. But here on the exponential, that's where my asymptote is. So I'm coming down and approaching 0, but I'm never actually getting to 0. Okay, point slope form. Point slope form is a form of a linear equation where we have the slope and we have a point. Now these negative signs or these subtraction signs are part of my formula. So when I am going to go and write this, I'm going to just write out kind of like a template and I'm going to fill in these numbers. So the y value here at this point is 1, 2, 3, 4. So I'm going to put a 4 right here. The x value at the point is -2, so I'm going to put a -2 right there. And now I'm going to count out my slope. So I'm going to find another good point, like right there, and I'm going to count. So 1, 2, 3, 4, 5, 1, 2. So it's down 5 to the right 2. And I'm just going to clean this up a little bit, taking care of that double negative, making it a positive. Okay, in number 3, they actually gave us all the information I need, so I just need to fill everything in. So y minus my y value equals my slope times the quantity, x minus my x value. So they said that the y value was 5, my x value was -3, my slope was half, and again, I need to change that double negative to a positive. Now that can happen with the y as well. In both of these examples, it was the x that had the negative, that we had that double negative that we changed to a positive, but it could happen in the y's as well. It couldn't happen at all. It could happen in both of them. Kind of just depends. Okay, moving on to transformational form. Transformational form looks very similar to point slope form, except we don't have y minus y1. We actually add that y to the other side. And we're going to actually change the m, the x, and the y to a, h, and k. So it just matches for all the other problems that we're doing. So let's start by writing out just where we're going to fill some stuff in. Now remember, this negative is here, but this is a positive. Well, as long as the point is a positive number. So we're going to fill that in just how it is. Okay, so let's see what this point is. 1, 2, 3, 1, 2, 3, 4. So it's the point 3, 4, both positive. So my 3 is my x value. It's going to go here, and my 4 is going to go there. Okay, now I've got to figure out my slope. So I see another good point right there. So I'm going to count up to 1, wait, up to, erase that, it's confusing me. Okay, up to, and then 1, 2, 3. Okay, 2/3. And there's nothing I need to do here. I don't have to clean anything up because I don't have any double negatives. Okay, for number 5, I have y equals, and there's my a, x minus h plus k. So it's telling me where I'm moving. Remember on my parent function, remember how I was like that? This is telling me how I'm moving. So I moved my point over 7 to the left and down 1. Now remember, I can use either one of these points. Doesn't matter. So I'm just going to use the 7 and the 1 just for fun. Okay, so if the x value is -7, I'm going to make that a -7 in there. The y value is a -1. And then my slope is down 1 or down 2 to the right 1. So cleaning that up, y equals -2, x plus 7 minus 1. Okay, and last example, again, I can use whichever point I want. I'll use this point down here just for fun. So y equals a, x minus h plus k. Okay, so my point is 5, -2. So 5 here, -2 there, and I've got to count out my slope. So 1, 2, 3, 4, 5, 6, 7. So down 7 to the right, 1, 2, 3, 4, 5, 6, 7. So -7 divided by +7 is -1. X minus 5 minus 2. Okay, so in a quadratic function, we are going to state the transformations and then sketch it. So with our a value, which is the coefficient out in the front, if it's negative, it is going to be opening down. It's going to be a reflection like that. It is a vertical stretch if a is greater than 1. And it's a compression or wider if a is between 0 and 1, like a fraction. So I see this negative. That means I have a reflection over the x-axis. I see I have the +1. That's my horizontal shift. Remember, it's opposite when it's on the inside. So that's left 1. And then I have the -5. That's down 5. I also have a 2 here, which makes it a vertical stretch. Okay, so if I draw this, I have to move left 1 and down 5. That's here. I need you to be skinny because it's a stretch, and it's got to reflect, so it's got to face down. So it's going to look something like that. 1/2 x squared plus 1. I have a half, so that's a vertical compression. I don't have an h because there's nothing on the inside of the x squared. I just have the +1, so that's up 1. And that's actually all I have. So a vertical compression means it's going to be fatter, and I'm just up 1 unit. So looking something like that. On an absolute value, it actually works the exact same way. It's just a V shape. So same thing. A vertical stretch is going to be skinnier. A vertical compression is going to be wider. A negative is going to be the reflection, so it's going to face down. And same thing. H is our horizontal transformation, left and right, opposite of what we see. And the vertical translation is the K value, up or down. So we see that we have a reflection because of the negative. And then we have the +2, which is up 2 units. So this is that V shape. And I'm up 2 units and I'm reflecting. And because I don't have a stretch or a shrink, the slope of those lines should be +1 and -1. You know, if you're just trying to, get it to look pretty accurate. Okay, in this example, I have my 3, so that's my vertical stretch because that number is bigger than 1. And then I have an inside horizontal transformation, so that's opposite. So I'm going to say right 2 because I have the x minus 2. So right 2, there's my vertex, and it should be 3 times as skinny. This slope should actually be 3, so it should be up 3 over 1. 3 and -3 is the slopes of those two lines. Okay, here on the exponentials, so we still have the same AH and K, and it literally does the same thing that we were doing before. If A is bigger than 1, that's a stretch. If A is between 0 and 1, like a fraction or a decimal, that is going to be our shrink or our compression. The negative is going to be the reflection. H is left and right. K is up and down. So I actually didn't mean for both of these to be negative. So let's get rid of that one just for fun. Okay, so this is going to be my reflection. And then my minus one is an H, so that's right one. That negative 2, the 2 is the base, and that means it's growth. So don't think that that's your stretch. That A value is actually just a 1. The B is what this 2 is because it's the number that's being taken, that's attached to the power. So remember, exponential growth looks like that. So we're going to reflect that and move it to the right one. So instead of having that y-intercept at 1, 1 or 0, 1, it's going to be at 1, 1, but then it's going to reflect, so it's negative. So it's going to look like that. Just scooting to the right a little bit. Okay, so if we change this to a positive, then this one is just going to be up 3 units. So that's where my asymptote is going to go. That would mean my y-intercept is now at 4. I just wanted you to see these ones because of domain and range, or not domain. Domain's always all row numbers, but range, this would be y is less than 0 because it reflected. Moving right and left doesn't change your range, but this one's range would be y is greater than 3 because we moved up 3 units. Okay, last section is about absolute value and completing a table and evaluating. Oh, and then we have some domain and range. Okay, so it says evaluate the expression for s is equal to -6. So that means we're going to substitute in a -6, simplify inside of the absolute value, and then if it's negative, we make it positive. So 4 minus -6 is the same thing as the absolute value of 4 plus 6, which is 10. Absolute value of 10 is 10. If it's positive, it stays positive. Then we have -2 times the absolute value of -7 plus 4. Because there's nothing else inside of the absolute value, we will take the absolute value of -7 right now. So the absolute value of -7 is +7, and then we'll add 4. So -2 times 7 is -14, plus 4 is -10. And last, we have -4 plus the absolute value of m. M is positive in this case. So if it's positive, you keep it positive, and -4 plus 7 is 3. Making a table, I'm going to do the same thing, just multiple times. So I'm going to plug in the absolute value of -5 times -2, which is -10, or I'm sorry, a negative times a negative is a positive. So that's the absolute value of +10, which would stay positive. The absolute value of -5 times -1, well, -5 times -1 is +5. Absolute value of a positive number stays positive. -5 times 0 is 0. The absolute value of 0 is still 0. And then this is the only one where we actually have to use the absolute value. So -5 times 1 is the absolute value of -5, which is +5. Okay, plugging in 7, 8, 9, and 10 for C. So plugging in a 7. 7 minus 8 is -1. Absolute value of -1 is +1. And 1 plus 4 is 5. Okay, now we're going to substitute in an 8. So the absolute value of 8 minus 8 plus 4. Well, 8 minus 8 is 0. The absolute value of 0 is 0. And 0 plus 4 is 4. Okay, next we're going to substitute in a 9. So 9 minus 8, absolute value, plus 4. 9 minus 8 is 1. The absolute value of 1 is 1, and 1 plus 4 is 5. And last is 10. Absolute value of 10 minus 8 plus 4. 10 minus 8 is 2. The absolute value of 2 is 2. And 2 plus 4 is 6. Okay. Oops. Last section. It says find the domain and range of each function. So we already know that the domain is all real numbers. For all of these continuous functions. Now the range just depends on my vertex or my asymptote. So in an absolute value function, we have a vertex. The vertex is the minimum on this one. So that means that my range is y is greater than or equal to 0 because 0 is the minimum. Everything is above 0. In number 17, I have a exponential equation, and so I have an asymptote right here. Let me count to see where that is. 1, 2, 3, 4, and everything is below that asymptote. Now remember, for an asymptote, we don't actually touch that or cross that. So I'm not going to say greater than or I'm not going to say less than or equal to. I'm just going to say less than 4. And last but not least, we have this parabola, and my range is based upon my vertex, and my vertex is down here at -1, and my whole graph is above it, so y is greater than or equal to -1.